Hit subscribe, become part of our crew, and let's explore the wonders of math together.
Hello, we're looking at position vectors. So here we have two axes, the x-axis and the y-axis, and they both intersect each other at the origin, labeled here as O. Alright, so we're talking about position vectors, and a position vector is a vector that starts from the origin. And so we have this vector, this line that starts from the origin, and it goes on to point P. Now let me use this arrow on the vector itself to indicate the direction of the vector. Now a vector has both size and direction, and so this is the tail of the vector, the origin, and this is the endpoint of the vector. Alright, so we're going to consider that to be a point P. Now point P has location on the x-axis as well as on the y-axis. And so we'll say that point P is located at a certain x value, we call that the x coordinate, and a certain y value, we call that the y coordinate. Okay, and so vector OP, that is this line going from the origin to point P, is the displacement of P from the origin. So vector OP, that is position vector OP, is called the position vector of P. Clearly indicating it's a position vector because we start from the origin. So position vectors start from the origin as indicated before. Any point, in this case point P with coordinates x and y, can be represented by a position vector. Any point, because we can always draw a straight line from the origin to that particular point. And so again, any point in example P with coordinates x and y can be represented by a position vector or column vector. So vector OP, that is position vector OP, is equal to the column vector with components x and y. Notice that we have point P with coordinates x and y and position vector OP with the same values in x and y. Now, if you want to find the length of this position vector, this is how we symbolically represent it. We use two straight lines at either side of the notation vector OP, and we put the equal sign square root of x squared plus y squared. Now this comes from the Pythagorean theorem. You can check my videos out on Pythagoras theorem. That will help you to understand that concept. Now the vector OP makes an angle with the x-axis. We know that when two straight lines meet at a point, an angle is formed, and the angle formed between the vector OP and the x-axis we label as theta, the Greek letter representing the angle formed between those two lines. Here's an example. Given the point with coordinates 6, 3, determine the length of or magnitude of vector OP. Now this is how we do it. We take the formula that we take the formula that we have stated is the Pythagoras theorem, and we write the formula x squared plus y squared. And what is the x component? Well, the coordinates of P are 6 and 3. That is x equals 6 and y equals 3. And so when we look at vector OP, position vector OP, its components will be, as a column vector, 6 and 3. And so we'll replace the x and y with 6 and 3 respectively. So we're going to say 6 squared plus 3 squared. And that will give us 36 plus 9. Then we will find the sum, which gives us 45. And then we'll find the square root of 45. The square root of 45 is equal to 6.708 and so forth. Now let's say we want to have three significant figures. The first significant figure is 6 because it's not 0. The first significant figure always starts with a non-zero digit. And we count up to 3. Now this 0 is significant because it comes after a point and after a significant figure, a non-zero digit. So it makes it significant. But also because it's between two non-zero digits, that zero is significant. All zeros between non-zero digits are significant. Another point to take note of. Now, the first digit we're chopping off, because there are some more digits after the 8, but we always look at the 1, or consider the digit that comes after the required decimal place or significant figures. Because it's in the category of 5 or more, we will add a 1 to the required place. And so we'll add a 1 to 0. And so this will be 6.71. So again, we always check the digit that comes after the requirement, the very first digit that is, and it's 5 or more, we add 1. Now, if this were, let's say, 4, a 3, a 2, a 1, or 0, we'll leave it at 6.70. All right, and this is in units. Okay, so now let's look at how we can find the angle between the position vector and the x-axis. Now, this is a formula, and it comes from trigonometric ratios, sine, cosine, and tangent. And we know the tan ratio is opposite over adjacent. So what happens here is that this vector, along with the x-axis, creates a right angle triangle. And so this side will be our opposite, which is the y value. The distance traveled upward vertically is in relation to the y-axis. The distance traveled horizontally is in relation to the x-axis. And so it's going to be opposite over the adjacent side, the y divided by the x. And obviously, since we find the angle, it's going to be tan inverse. Now, again, you can check out some of my videos on trigonometry. That will help you. So let's look at this. Given the point P with coordinates x and y, so we're using the same example from before to find the acute angle between the vector OP and the x-axis. So we write the formula that we are given. Theta equals tan inverse of the opposite side. That should be y, since we're looking at the opposite side. One moment. All right, so that's going to give us y over x. And so we have tan inverse of the y value. Now, again, since we're saying that this is going to be, the location of P is 6, 3, we're talking about 6 horizontally. So we go 6 units to the right and 3 up. So 6 to the right was x equals 6, and 3 up, y equals 3. And so we recall that the position vector OP as a column vector is 6, 3, just like the coordinates of P. And so remember, the first component is our x component, and the second component is our y component. And in the formula tan inverse, we have y divided by x. So we take the second component, put it on top, since that's a y component, and divide it by the x component according to the formula, which is 6. We input that in our calculator. Depending on the calculator you have, let's say you have a double display calculator, you're going to put shift, and then you're going to press tan, and you should see tan inverse in the calculator. This symbol here with the negative power means tan inverse. Once you've seen that in the calculator, put open bracket if it's not there already, and then you're going to press 3 divided by 6, close bracket, equal. Now your calculator should be in degree mode. Now if you're not sure what I'm talking about in regards to this, then you would want to check out my videos as well in trigonometry using the calculator. Okay, so this should actually give you 26.565, etc. Now I only want 3 significant figures. You could be required to use 2 significant figures, etc. But let's say they're required to use 3 significant figures. So we have 1, 2, 3 significant figures. Check the very first digit that you're chopping off. It's in the category of 5 or more. Meaning could be 5, could be 6, could be 7, could be 8, could be 9. Once it's one of those digits, from 5 to 9, you're going to add 1 to the last digit in the required significant figures. So we have 1, 2, 3. So we're going to add 1 to the 5. So this will give us 26.6 degrees. Again, angle is in degrees. All right, so let's look at some more examples. Now this is from the Tool C textbook, as mentioned before. Let's look at it. Yes, this is the Raymond Tool C Mathematics A Complete Course, Volume 2, page 1035. Examples and questions. Okay, so question 11. We told that point P has coordinates 6 and negative 8. Determine the vector OP, that is the length of vector OP. And we know that OP will be the same as the coordinates, 6 and negative 8 as a column vector, so 6, negative 8. Okay, now we want the length. Now to calculate the length, we use the length symbol, these two lines, the left and right of vector OP, and then we write the formula, x squared plus y squared. Next thing, we're going to take the components, and by the way, we're going to take 6 squared plus, and we're not going to use a negative. Even if we use it, it's pretty fine. We can just substitute it in bracket, but we're going to use a positive because we're dealing with length of line. The Pythagoras theorem deals with length of line. For instance, we're looking at 6, negative 8. It means that from the point, from the origin, we go, because this is the x component, we go 6 to the right and 8 down. And so then we connect those two. That will be the vector we're looking at here, vector OP. We go 6 to the right, 6 units to the right, and 8 down. But when it comes to length of lines, length of line is always positive. If you're going to measure something, measure a line, it's going to be just positive numbers. So we take the positive. This negative just meaning we're going downwards, but it's 8 units in itself. It's 8 units, the length of it, and this is 6 units. Okay, so we can use just positive in the formula. And so this will be 36 plus 64. This will give us square root of 100, and that will be 10 units. Again, the Pythagoras theorem is concerned with the lengths of lines. So we have in a triangle, a right angle triangle that is, we have 3 sides. The hypotenuse, which is this side that we're trying to find here, which always face the right angle, and then the other 2 sides. And so you can check out my video on that to learn more. All right, so we're going to go to the formula to find the angle between the acute angle between, sorry, you're going to find it, to find the acute angle, use the formula that deals with the lines of the vector OP and the x-axis. And so this is, we're trying to find this angle here, okay? And this horizontal line will be the x-axis, and this vertical line here will be the vertical direction with regards to the y-axis. Okay, and so in order for us to find this acute angle, we use the trig formula, tan. All right, so you can again check those videos out. They will pretty much go in depth with that, but we're just using the formula that we have here. The y component is 6. So let's look at it. The y component is negative 8, but again, the trig formula also just deals with the measurements on the triangle. Again, and measurement will always be positive. Okay, so we have 8 units in terms of the y component. What's the length of that line? Is 8, actually 8. So we use a positive of that negative 8. So it will be positive 8 divided by the x component, which is 6. And so we'll get, let's put that in our calculator, tan inverse of 8 divided by 6. And that will give us 53.130, etc. 3 significant figures. All right, this digit, the first of those chopping off, is less than 5. Once it's 43210, less than 5 that is, we maintain this last digit, which is a part of the required amount. So we be 53.1 degrees. Again, angle, we'll measure in degrees. Let's look at the next example. We have the point P and Q, which both have location 2, -4 and 6, -8 respectively. So this is P, this is for Q. Based on the order which we call them, right? P and Q. So this one is for P, this one is for Q. Okay, so let's look at that. Express each of the position vectors, position vector OP and position vector OQ, in the form of a column vector. So we're going to write position vector OP, which has the same components as the coordinates of P. Remember, position vector OP relates to point P. We're looking at the position vector of P, and this is how we write it. Position vector of P is written as position vector OP, same units. And the next one, being position vector OQ, will have the same units as well as Q, 6, -8. Okay, and so now we've completed that. They just want us to express each in the column vector format. We have done that. Now let's look at the point, part B, which tells us that we must add the position vector in the column vector format, right? Add position vector OP to position vector OQ, and we should get vector C. So let's do that. So we looking at part B. Okay, so we have 2, -4 for position vector OP. We have 6, -8 for position vector OQ. And we add them, it should give us position vector. It should give us the vector C. So 2 plus 6 give us 8, and -4 plus -8. Use your calculator if you don't know that. Well, the signs are the same on the numbers we're adding, so we add and keep the sign. That's -12. Okay, so we have found the components of vector C, and now we're going to do the last part. They ask us really to determine the length of, remember these two lines mean length, right? Combined together, it means the length of the vector. So the length of vector C, and we use a formula. The formula for the length of the vector is x squared plus y squared added and square rooted. So we input the formula, we input the values in the formula, that is, so we have 8 squared plus, we're going to use a positive of this since we're dealing with length of line. In other words, this vector C, we move 8 units to the right and 12 units down. Okay, so it's going to be, the length of this side is 8 units, the length of this side is 12 units. And using Pythagorean theorem, again, we square both sides, add them and square root them to find the length of the hypotenuse, the side that faces the 90. If you're not sure what I'm talking about, that's fine. Just go through the videos and just simply use this formula. In this case, use a positive value here, and we're going to get 64 plus 144, and this we're going to give us, let's add those, is going to give us square root of 208. 64 plus 144 is 208, and let's find the square root of that. That gives us 14.42 units, 22 units, etc. So we're gonna just simply take the first 3 digits. These are 3 significant figures. The very first we're chopping off is less than 5, is 2. So we're gonna just maintain the 14.2 units as our answer for the length of vector C. Okay, and that's it.